can be used for process intensification, and I now realize that it's now been accepted as a most probable technique for ballast water treatment amongst the other 7 developed by scientists in Japan, Germany, USA, etc. And those days, I believe, some preliminary experiments and some publications were being done. Professor Pandit has unique distinction of getting 2 best institutes in the country, ITBHU and UDCT, as his alma maters, and he is a distinguished alumni of both of them. He's also worked in University of Cambridge, UK as a research associate. He's got several awards. I'll just name a few. The Vasvik Award in 1996, IICHE's Hardley Award for Excellence in Fundamental Research in Chemical Engineering 2001, Distinguished Alumnus Award of ITBHU and IICT UDCT. He's the recipient of Best Teacher Award almost 15 times, and also from INSA in 2012. Professor Pandit has authored over 300 publications, 3 books, 10 chapters, 13 patents with 7,500 citations, and is in the editorial board of several international scientific journals. He has guided 34 PhDs and 60 master's students so far. The most interesting part about Professor Pandit is everything he does in life, he examines it with a very scientific angle. In fact, I remember there was one discussion we had over a cup of tea about taking a lecture is strenuous, and Professor Pandit already had that on that. He said a professor who takes a serious lecture for 1 hour is likely to lose 1 kilogram of weight by the end of the lecture, and that was the kind of this thing he brings to the table. Professor Pandit simplifies chemical engineering to a very down-to-earth level and applies it to day-to-day life. I don't know what would be the weight gain for the students after that 1 hour lecture. I guess it's time that we find out. So Professor Pandit, without much ado, let me invite you to them. And I guess we will move down and enjoy your lecture, sir.
My approach to the research. And that's the reason I have chosen today's topic as chemical engineering forays into rural India. I would like to thank UPES for inviting me for this distinguished lecture. It's an honor for me, and I am but a small fry in front of the people who have given these distinguished lectures earlier. Professor M.M. Sharma, who was my teacher, as he is my teacher, Professor M.S. Anant, Professor Gandhi, all those I have had an opportunity to collaborate with them at some point of time, have learned many things. And I'm going to talk today trying to tell you that we, the chemical engineers, are in a way a unique species among all the engineering species, and I'll tell you how we are different, why we are different. And unless we treat ourselves differently, we will not be able to use that difference for the does work for industry. It does something because of which the industry benefits, and maybe we do use products of chemical industry, but they are not apparently easily explainable to the general masses. So I would like to break this perception and show and indicate with some examples that that is not the case. The basic chemical engineering principles are equally applicable to each and everything on this earth, and I'm going to give some examples in due course where the basic chemical engineering principles have been extended, applied to problems in a way which are not glamorous, but the problems which are likely to have a huge impact on a society, and especially the rural India. Is associated with petroleum refineries. They are the people who make plastics or develop plastics or plastic products, fibers, tires, and of course the modern electronic devices, the operations where the chips are made, the operations which are followed to make these products are all chemical engineering operations, and I'll tell you how they are. But the general perception of the general masses is this: chemical engineers are the one who has been responsible for polluting the atmosphere. They are the people who have destroyed the environment. At the same time, please try to understand, they are the people who are going to likely to find solutions to that as well. They might have created the problem, but they are the people who will find solutions. So this is a typical general perception, and it is necessary for us, chemical engineering fraternity, to change this particular perception. I will show you this perception can only be changed if each and every person understands the capability of chemical engineer and what chemical engineer can do for the society. That's the reason why this particular talk has been chosen. The title of the talk has been chosen. If you ask a person in an urban area, then you'll find that yes, chemical engineers have been responsible for development of large-scale medicines, which has resulted into cheaper availability of medicines. They have been responsible for synthesizing many materials, including biomaterials. They have been responsible for mass-scale food processing. Again, these are all, you can imagine, heat and mass transfer operation. I'm sure this joke you might have heard, chemical engineer is nothing but a glorified cook. He does all those things which you tend to do in the kitchen. The only thing is you tend to apply the basic scientific principles to these cooking operations, where chemical, physical, biological changes are taking place when you make a specific food item. And chemical engineers are the one who have modeled these particular processes, who have used the basic fundamental principles to model these processes, and able to scale up these processes, which the cost of production was possible. You can imagine, if you want to make bread yourself, then the quantum of energy which you use, the quantum of efforts which you use, and if you compare that cost, and I'll give you some examples later on, as compared to a bread which you will buy for rupees 30, 400 grams, if you put all the efforts which you have put, you will find that you are paying and spending much more than that 30 rupees. And that has been possible only because of efficient scale-up of these operations. Development, use of fertilizers, combining with agricultural scientists, they have come out with different and newer crop varieties. They have been responsible for preserving food using drying. Again, drying is a classical chemical engineering operation. Large-scale food processing, this is but there are other things which are also there, which are less glamorous, where chemical engineers have not necessarily contribute, but can contribute. Jaggery production, chemical engineers have contributed to sugar production, but chemical engineers have not contributed scientifically to jaggery production. Now, if chemical engineers can contribute, then the efficiency with which the jaggery is produced can be significantly enhanced, and it has huge implications in terms of national economy. We are responsible for sugar mill, alcohol production, compost making. All these are chemical, biochemical, physical changes which are taking place, which are essentially taught to each and every chemical engineer. Water purification, of course, has already been discussed about. Biogas, burning of gas for cooking purposes. Now, you can imagine it's extremely difficult to publish a paper in this particular area in any chemical engineering scientific journal, but let me tell you that it is not impossible. Difficult, yes indeed, but if you approach any problem with the fundamental basic chemical engineering principles, it is possible for you to publish this in a good scientific journal which will have a scientific impact as well as a social impact which you want to express. Realize the fact that a huge amount of money is being spent on us and we owe something in return to the society in terms of our learning, in terms of practicing our learning. And I'm going to choose certain topics which are of relevance in the national context and see how chemical engineers can contribute or have contributed to these particular topics. This is what differentiates chemical engineers from all other engineering branches. This is the only branch of engineering where material and energy balance is taught. So what is going in, what is going out, the difference is being converted into something, the difference is being utilized into something. 3 months ago, I gave an assignment to third year chemical engineering students. I said that for next 1 month, starting from tomorrow, stand on a weigh scale, weigh yourself, and for 1 month, note down all the resources which you have put or which you have utilized. Consider your body as a closed system, and whatever going in, whatever going out, weigh yourself every day and see whether you are able to establish this material energy balance about your own self, and you will realize what sort of basic principles are required in terms of understanding of metabolic rate, understanding of conversion of sugar into fat or accumulation of the fat. All these concepts will start becoming clear if you take a real example of yourself. Similar to cooking, our human being is also a biochemical system, and chemical engineers are capable of understanding this particular biological system or biochemical system, and it is possible for us to look at any system and do material energy balance. And that's why you will find that chemical engineers are good accountants as well, mainly because they understand money is coming in, money is going out, something is being done, money is accumulated, you get interest on it. It's again balance, some sort of a balance. So the basic concept of material energy balance, the equation of continuity, the Navier-Stokes equation or equation of energy, these are the two things which differentiates you from any other engineering branch. And if you forget this, then you are no longer a chemical engineer. And I'll give you and tell you through the examples how these basic concepts of material energy balance can be utilized for a variety of operations, be it industrial, be it rural, and these operations then will give you answers which you would not have expected it otherwise. So let's move our attention and see what are the basic chemical engineering operations which you learn. Filtration, evaporation, heat exchange,